Textbook section 8.3, question number 9. Here they are asking us to find the approximate margin of error and 95% confidence interval given a sample size n and a sample proportion 0.4. So this is p hat, a single samples proportion. To attack this question, we can use the same concept that we learned about the distribution of sample means x bars, because whatever was true about the distribution of sample means is going to be true for sample proportions, because we explained in our class that sample proportions is nothing but a special case of sample means. So they are essentially the same thing. So just like if we had a population mean mu, suppose this is my population, and the population standard deviation sigma, if we drew thousands of samples from this population and calculated the respective sample means, we would get a histogram which would look like normal distribution, and the mean of all these sample means would be exactly equal to the population mean. Similarly, in the case of p hats, from a given population of thousands of observations, if we drew thousands of samples and calculated the corresponding sample proportions and plotted these thousands of sample proportions on a histogram, the histogram would be normal, and the mean of all these thousands proportions would be exactly equal to the true population proportion. And if the population proportions standard deviation is sigma, the standard deviation of all this p hat distribution is going to be exactly sigma over square root of n. However, in the case of proportions, the standard deviation of the proportion, the sigma, turns out to be equal to square root of p times 1 minus p. So if you cannot keep this in mind, you can always use your cheat sheet in your exam, so that's not a problem. You don't have to even memorize it. And to find the standard deviation of p hat, therefore, on the numerator, instead of writing sigma, I'll just write square root of p into 1 minus p. And we'll use that formula to calculate our sample proportions standard deviation. Now we know that margin of error for a 95% confidence interval is simply equal to 2 standard deviation of the distribution of x bar if we're talking about x bar, and p hat if we're talking about p hat. So let's just plug in the values of this sigma p hat that we have just derived here. So this turns out to be 2 times square root of p hat into 1 minus p hat. Now notice that I am replacing these p's with these p hats because I do not know the true population p. P hat is the second best approximation of p that I can use, so I'm just going to use these p hats here. Square root of n on the denominator. Let's plug in the values. On the numerator, I have square root of 0.4, which is this guy, times 1 minus 0.4 would give me 0.6. On the numerator, I'll have square root of 1000, the sample size. Now if I use my calculator, inside this square root I have 0.4 times 0.6, which is 0.24. So let's write that down on the numerator. I have 2 times 0.24. On the denominator, I have square root of 1000. So let's figure that out. 1000 square root is 31.623 approximately. 31.623. And if I simplify this, square root of 0.24 square root turns out to be 0.489, which is 0.49 approximately. So this is 2 times 0.49 divided by 31.623. So on the numerator I have 0.49 approximately times 2. So let's multiply this guy with 2. And this is my numerator. And let's divide that by 31.623. Divided by 31.623. And the answer is 0.03 approximately. 0.03, and that is my margin of error for this estimation, which means that I am 95% sure that around my single samples p hat, which is 0.4, if I build a plus margin of error and minus margin of error interval, this interval will contain the true population proportion. And the lower bound of this margin of error is of course 0.4 minus 0.03, which is 0.37, and the upper bound's value is 0.4 plus 0.03, being equal to 0.43. That is my 95% confidence interval, i.e. there is a 95% chance that the true population proportion lies somewhere between 0.37 and 0.43. I hope that helps you to understand how to attack a question that asks you to find margin of error or confidence interval given a sample size and sample proportion, or population proportion for that matter. Thanks. I'll be back with some more answers hopefully soon. For now, I'll say bye.